So here's the next example. Here we aren't given a filled out chart, we're given an equation. Now we can use this equation to fill out a chart. So I'm going to say that this, we'll put the x values here, then we'll put the y values here. So when you're filling out your own chart, you need to use your own numbers, okay? Because they're not giving you numbers for x and numbers for y. So we just have to say, well, what if x is -3, for instance? So I'm just going to decide on -3. I usually choose small numbers near 0, and I choose numbers that are negative and positive. So -3 is a fairly small number. I'll plug in. And so if x is -3, then so -3 minus 2, that would equal -5. So then y has to be -5. So plug that in there. Now let's say x were, let's try 0. If x is 0, what happens with y? Well, if x is 0, 0 minus 2 would equal -2. So that means the y value is -2. So if x were, let's say, 1. If x is 1, what is y? So 1 minus 2 would be -1. So that means the y value has to be -1. Now I'm choosing kind of my own random values, but they're not entirely random. Like I said, I'm picking small numbers, so they're easy to calculate. They're also easy to graph. If I chose 20 for x, it's going to be tough to fit that on the graph with numbers like -3, 0, and 1. So that's why I'm not choosing 20. I'm going to choose, how about 3? Sounds good. So with 3 minus 2 is equal to 1. So then the y has to be 1. Notice how I have it lined up there in the just under the equation. I'm putting all the x values where x was and putting the y values where y was. So I'm just keeping it lined up. So now I have my data. My x's go from -3 to 3, and my y's are mostly negative. So in this case, I might draw my my x-axis higher because most of the values I'm going to use are negative. Okay, and again, I'm going to use 2's just to keep everything spaced out. -2, -4. 2 is up here, -2, -4, -6. And I'll use blue to graph. So I have -3, -5, which goes about here. 0, -2, about here. 1, -1, and 3, 1. Now in this case, the chart I have here, I made up myself. What I'm actually graphing is y equals x minus 2. Now I chose to plug in whole numbers and integers because they're easy to calculate. However, I could have plugged in a fraction and gotten another fractional answer. So if I would have plugged in, like, let's say 2.5, well, 2.5 minus 2 is 1/2. And so graphing that would be about 2.5, 1/2. You notice it's on that same continuous line there. And so this is one of those times where you would want to draw that line connecting the dots because it's not specified that x and y are integers. Whereas in a real world situation where you're talking about selling treats, you're going to sell 1 treat or 2 treats. You're not going to sell 2.5 treats. So you don't have to connect them to show that there's numbers in between whole numbers. Alright, let's do one more problem here. After graduating from Mrs. Malouf's babysitting club, you make $12 an hour at your new babysitting job. We can identify and define 2 variables, make a function, and graph this situation. So what we could say is the amount of money you make. So M, let's do black here. M equals money made. And we could say H equals hours worked. So our equation could be the amount of money we make is going to be equal to $12 times the amount of hours we work, which is shown by 12H. When you have numbers next to a letter, it means multiplication. And then we can fill out our chart here. So we could call this hours worked, and the money we make depends on hours worked. And we're not going to have negative hours because you can't work negative hours. So we could start at 1 and see what happens there. So if we work 1 hour, so 1 hour times 12 is going to be $12. And if we work, say, 5 hours, 5 hours times 12, that's $60. And if we work 10 hours, it's a little easier. 12 times 10 is $120. And let's say we put in a long month of work and we worked 20 hours and we made $240. All right, so now we have this chart filled out. We notice that we have all positive numbers, so we don't need any negative values at all. So our x and y axis can go on the edges, right? So there's our y axis, here's our x. Now x and y is kind of the standard version, but we can call this now the h and m axis, right? The hours and money axis. So we need our hours to go from 0 to 20. So let's see, if we go 5, 10, 15, 20, that should work. So every 2 lines we could say is 5 hours. So 5, 10, 15, 20. And money needs to go up to $240. So let's see, if we go 50, 100, 152, that's not quite enough. So we could say every line is 50. We won't use quite all the graph, but we still get the idea. So 100, 200, 300. Now we can start graphing. I'll use purple. So if we work 1 hour, we get $12. Oh, this is money in dollars, of course, and this is hours. So 1 hour is $12. Now 1 hour is going to be, you know, if this is 5 hours, this would be about 2.5. So 1's going to be somewhere down here. And then $12, well, here's 50. So 12 is going to have to be, you know, pretty low down here. It doesn't have to be perfect, because when your dot's not on grid lines, you don't have to be perfect, but you'd like it in the basic area. So with 5 hours, we're going to make $60. So 5, here's 50, so 60 is going to be just above that. Not halfway, because that would be 75. Now with 10 hours, we need $120. So this would be 150, 100, so about 120, put it about right there. And then for 20 hours, we get $240. So that would be, well, here's 250, so it's got to be just below that. Okay. And I mean, you could work half hour or 15 minutes, and you could expect to get paid, you know, a part of your fee for that amount of work. So you could connect these, and notice again it looks pretty linear. The reason it's not perfectly linear is probably because my hand was a little shaky on that one. Okay, so there you go. That's how you can graph information from a story problem or from a chart or from an equation, and this is how graphs in magazines and newspapers and on the internet are made. Thanks for watching.